Alright, so today we're going to be looking at section 2.4. This is a polynomial and polynomial-like equations in one variable. I want to kind of give you a little overview before we get started because it can be quite a bit challenging for some, but if you see the pattern, then you'll realize that most of these are the same and you can do them the same way. So I just want to show you. So this first problem looks quite a bit messy. You have this z squared minus 6, and then it's squared, and then you got plus 7, z squared minus 6, and then minus 30. So, like this problem, most of them look quite a bit messy. I want you to notice a pattern. So, I'm not going to solve it. I'm going to try to write a few down because once I skip, I can't go back in the practice mode. I think it's even that way in certified. Like once you move forward, you cannot go back. So the first problem, I'm going to write that down. That is z squared minus 6 squared, and then plus 7 z squared minus 6, and then minus 30 equals 0. Okay, so I'm going to write that one down, and then I'm going to skip and just show you another one. So this one, again, similar setup, a little bit different. Z minus 4 squared, and then minus 12, z minus 4, and then plus 27 equals 0. Okay, and then I'm going to get a couple more, so that one is fine. This one I'm going to skip. You can kind of see. Notice that what is in parentheses is the same on both. Same thing here. And both of those have squared and then a non-squared and then a number. Squared, non-squared number. So I want to find one that's a little bit different, like this one, with the fractional part. Okay, and I want to explain all of these. So this was number 4. I skipped number 3. This was 2. 4, we have 3y to the 2/3 power plus 22y to the 1/3 power plus 24 equals 0. I'm going to write that one down, and then that one, you can do it. I really want to get a different one. I'll write this one and I'm going to find one more. There's several different ones. So we'll write 5. And I'm going through this again just so you can see the pattern. Okay, all of these problems will be worked the exact same way, even though they all look vastly different. 4 plus 6, and then let me get one more that's got, I want to find one that has a mixture, has a parentheses maybe, and then a fractional part. If we can find one like that, I think. Not this one. I thought there was a few more. I mean, I guess I can write one of these down. Has bigger exponent than the 2. What number is this? Number 9. Z to the 4 plus 7 z squared minus 144. Alright. I thought there was a couple more that looked really different. Okay, that might be it, because these are getting into some of the difference of cubes. Yes. Okay, so let's just pause there. So what I want you to notice is that we're going to work all of these problems exactly the same. I want you to notice the pattern. They all resemble quadratics. So if I look at a quadratic formula, ax squared plus bx plus c. Quadratic formula has the same variable. So all of these are in one variable. They all have the whatever variable they have in the problem is the same all the way through. Okay. These are z's, these are y's, z's, and this is x. And then the biggest relationship I want you to notice is the relationship between the largest exponent and then the term with the smallest exponent. So there's only two of them with exponents. This is 2, this is 1. This is exactly double. Or you can say that this one is half of what this one is. That is the relationship that you're going to notice in every single problem. So 2 and 1, if you were to double that, 2 times 2 would be 4, and then 2 times 1 would be 2. That relationship is exactly double or half, depending on which way you look at it. Double this, you get this. Or take half of that, you get this. Double this, you get this. Take half of that, you get this. And that's what you notice all the way through. So 1/2. The way you do exponents, if I were to multiply or actually take half of this, 1/2 divided by 2. That's how you take half. Well, when you divide with fractions, you do this method which we call keep, change, flip. You keep the first term, 1/2, change division to multiplication, and then you flip this term. So if you think about this as 2/1, when you flip, it becomes 1/2, and then you get 1, multiply straight across, 2 times 2, you get 4. So this is dividing this by 2, or if you were to take 1/4, 1/4, and then you multiply it by 2. When you multiply fractions, you just go straight across the top and bottom. 2 times 1 gives you 2. 4 times 1 gives you 4. 2 divided by 4 will reduce to 1/2. Okay, so that relationship is intact. Okay, if you take that smaller one and you double it, you're going to get exactly this. Same thing for the 1/3, and then same thing for these, even though they have these extra terms. So, even though all of these look vastly different, all of them are quadratic. We're going to solve all of them by factoring. Okay, so this term, when the first ones we have is something in parentheses, think about this as being x squared and then 7x and then minus 30. So I'm going to treat all of this z squared minus 6 just like an x. I'm going to treat the 7 like the constant, and then the z squared like my x, and then minus 30. So I'm going to factor this problem to solve it. So let me go through the factoring process, and again, or just to remind you, I have added the steps to factoring in your content folder. So if you go to content and you go to module 1, that's where I was, the steps to factoring quadratics are here. The difference of squares is here, and I also added the sum and difference of cubes here, which you will see in this section. So you can print those out and just follow those steps. The difference of squares and the sum and difference of cubes are just formulas, and if you just follow those formulas, memorize them, then you'll be able to solve any of those. But again, all of these are going to be the same. So you can use substitution and then go back. I don't like it because it just adds extra steps. However, it could make it easier for you if you need to do that. And then I solve it. With these, we'll see as I do them in my math lab. I will just use the properties of exponents to manipulate these as well. But again, remember that the relationship is always half. Okay, this is half of that, or if you take this and double it, you get that. Okay, and that's the relationship that you'll notice. And if you see that relationship anytime with 3 terms, you can do quadratic formula or you can factor it. I'm going to factor it, so I'm just going to show you. So again, how I would factor this, I would multiply the leading coefficient, the number out front, which is a 1, times the constant term, which would be 30. That would give me 30. I'm going to write the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay. I'm looking for the numbers that, because of the last sign is a subtraction, that you subtract to get 7. So 3 and 10. That means that this problem will factor. So I'm treating this as my x. Z squared minus 6 is my x. So I'm going to do two sets of parentheses and 0. So this is x squared, or z minus 6 squared, same thing. I'm going to put this term in both parentheses. This is like 1x here, 1x here. I'm going to do a z squared minus 6, the same way we would do with an x. Put it up front, z squared minus 6. And then at the back, we put the two numbers we found, 3 and 10. In order doesn't matter, you can put them in either one. Then we figure out the signs going left to right. The first sign is positive, so my bigger number from 3 and 10 is 10, so it's going to be positive. And then my second sign is negative. That means these are going to have different signs, so this is going to be a negative. All right, so we factored the problem, and then from here we're going to set each of these terms equal to 0. So I can't do anything in parentheses here. I'm just going to drop them. So what I have is z squared minus 6, and then minus 3 equals 0. And then over here I have z squared minus 6 plus 10 equals 0. You can simplify these, and then when you do square root, so this will give us z squared minus 9. I'm running out of room, you can't see that. Z squared minus 9 equals 0. You add 9, so that gives me z squared equals 9, and then you do the square root, and when you take the square root of the number, you have to remember plus or minus. So z equals positive or negative 3. So you get two answers here, and when we do this side, we're going to do the same thing. This is going to give us z squared plus 4, and then we're going to subtract 4, so we get z squared equals negative 4. And then when you do square root, you get z equals, now you cannot do the square root of the negative, so it's an imaginary. You can do the square root of 4 is 2, so you get 2i, plus or minus. So you get 4 answers, positive or negative 3, positive or negative 2i. And all of these problems we can do with factoring, which is what I'm going to do. And I just want you to see that even though they all look different, they're all going to be worked the same way because they have that relationship that quadratics have, where that middle term with the variable is exactly half of what this is. And you will notice that every time. If you multiply this by 2, you get the other power to the exponent that follows this relationship, which means we can factor, and that's what we're going to do. So just want you to kind of have an introduction, kind of overview, so that as you start doing these, you'll see the pattern.